Happy Monday, everybody. Brendan here today to talk to you about something that has me genuinely fired up because I think it's going to be one of the biggest shifts happening in AI right now. So, for the past couple of years, we've been watching this explosion of agentic AI, chatbots, co-pilots, voice assistants, tools using agents. But under the hood, it's been kind of like duct tape, super glue, custom APIs, fragile code. Every integration is a unique snowflake. But that is about to change. We finally have a protocol that can standardize how all of these AI agent tools and systems talk to each other, and it's called Model Context Protocol, MCP. I'm sure you've heard of it. So think back to the early internet, competing networks that couldn't talk to each other. It was all over the place. It was chaos. Then came TCP/IP, an universal protocol that stitched all that together. It made the web what we know it today. Everything worked seamlessly and just flowed. So that's exactly what MCP more or less is doing for agentic AI. MCP defines a simple universal structure. It's a universal communication standard for AI agents. So you've got your client, which is your AI brain, usually a large language model powered by a chatbot or a voice assistant or any app that can reason about what to do next. Then you've got your server, which is a toolbox, a system, or a swarm of agents. It could be a single endpoint or a whole ecosystem of logic, memory, tools, complicated or simple, right? But here's the key. No matter what's inside this server, this toolbox, a script, a model, a multi-agent planner, whatever, MCP, the protocol, it wraps it all together into a universal input-output interface. So let's zoom in technically a little bit for a second and use a hotel as an example. You arrive at the Grand Anthropic Hotel with a smart tablet. So this smart tablet is your MCP client. You walk into your room, it's too cold. You say, it's too cold. Can we make it 76 degrees in here, client? Those words are broken into tokens, which are chunks of language. Those tokens are embedded into vectors, which are high dimensional coordinates that live in a semantic latent space. It's sort of like AI's abstract magic land of data. That embedding is what sparks the agent workflow. Your tablet, the client, understands this and then pings the maintenance MCP server, which again is a simple toolbox in this case, and it calls the change temp tool. And then your room warms up. This is a simple synchronous task. One tool, one response, all automated through MCP. Okay, great. But what happens if you want something more complicated? You speak to your client or type to your client, I want a 7-course French tasting menu for dinner. Again, your words are broken into tokens and embedded into vectors. This isn't just a request for food. This represents your intent, your emotion, your theme through these vectors. From there, your MCP client evaluates the task and says, okay, I now need the kitchen MCP server. It sends a structured JSON RPC request. We'll get into that later. And inside that server, a group of specialized agents wake up and start this task. So in this kitchen MCP server, you've got a head chef agent, which takes the lead. It collaborates with a pantry agent, a pastry agent, a prep agent. They all reason together using shared memory and invoking tools like check fridge for filet, check wine pairings, preheat oven to 450. They loop, they revise, they adapt. The contextual memory they might be using could be built on something like LangChain, which helps manage agent states, tool selection, memory retrieval, and dynamic reasoning flows. There has to be some way that this all kind of like speaks together and remembers things, right? So yeah, more on that later. So now this is where the magic really happens though with MCP, as if all this stuff wasn't amazing enough, right? Once you leave the Anthropic Hotel, and let's say you travel again across the country to a new boutique fitness resort hotel extravaganza, your same client tablet can now connect instantly to new MCP servers. It can now connect to the new kitchen MCP server in this hotel, the new maintenance MCP server in this hotel, the new gym server MCP server in this hotel, the new spa MCP server in this hotel. And it can speak universally to all of these new protocols and servers inside this new hotel seamlessly without any integration. No installs, no custom integrations, no guessing at APIs. It just works. But not only that, anyone with their own MCP client, their own little tablet version or whatever you want to call it, can access all the same MCP servers, services, tool calls, whatever, that you've been accessing as well. So it's a global accessible system allowing the same global benefits for everybody that has access to these MCP servers. So MCP servers allow LLM clients access to a wide world of reusable agentic options. It's crazy. So here's an important point. Depending on the task or product, that you can architect this a little bit differently. Sometimes all the agents that you need live in a single MCP server, like a tight-knit kitchen team in one kitchen MCP server, for example. Other times, each domain lives on its own server, like a hotel with separate rooms, right? You've got a kitchen MCP server, a maintenance MCP server, a spa MCP server. But what's cool is that each server can also act as an MCP client. If it needs to communicate with another server, such as the kitchen MCP server needing to ask the room service MCP server to deliver the food to the original client, in this moment, the kitchen MCP server has become an MCP client, calling the room service MCP server. That's a little bit confusing, but basically it all works together seamlessly and then kind of go back and forth and make everything kind of function. So the specific setup that you have is going to depend on how complex the ecosystem is that you need, how much modularity and optimization you need, and how your agents need to share memory or states to achieve their different goals. One thing that I'll note is that when you're building MCP clients, having a RAG framework in play with a specific vector database for whatever organization or your customer needs are can greatly improve productivity for the overall state system, because your client can then tap into that pre-existing information and database, and it more directly kind of helps it understand what it's doing. It removes more need for human input or longer drawn out communications with your MCP client, so it can get to the heart of what needs to be done faster. So it won't need to ask you as many questions about, oh, okay, like you have this order, well, what's the order number? Oh, I already know it because I can go and find it in the database. Now look, MCP isn't a silver bullet. If you're building a super specialized agent, say a high frequency trading bot with millisecond latency or an internal model that hits proprietary endpoints, wrapping everything up in MCP might feel a bit restrictive. MCP introduces some structure. That's a good thing at scale, but it's not always the fastest route when you're building something deeply custom or experimental. In some cases, a tailored integration, purpose-built API, contracts, or direct model calls may still win out over this particular protocol. And also, this protocol is amazing, but it's early days. So like any new protocol, it's going to evolve. And some folks in the community have already raised important critiques, like, MCP uses HTTP and server sent events with JSON RPC, which is super simple and flexible, but it's not always ideal for high performance use cases, especially if you're building something like a robotic swarm or a high frequency trading system. But that said, the protocol authors have been very clear that MCP is a transport agnostic system. That means you can swap out the HTTP JSON layer down the road, and I fully expect that we'll see future iterations that introduce, richer schema support, pub sub capabilities. But for now, it's a lean MVP that gets the job done, and it gives us a common foundation to build on. So if you're building on this, just remember that the wiring of the MCP system protocol is powerful, the ideas are sound, but the standards are still evolving. So if you're shipping production critical infrastructures, do your due diligence. Don't assume MCP is the battle-tested at-scale solution just yet. It's going to evolve. Things will change, but for sure it is the future. So again, MCP isn't right for every agent, but soon it likely will be, and I imagine for sure it will be. So, this is how we evolve. From prompt hacking to system engineering, from brittle scripts to intelligent modular ecosystems, MCP is here to stay. And again, the future is agentic. So, let's build it.